solid, either powdery or some granular, powder or some granular mass. So this flux material is provided, and they completely say, you just imagine, say if some if you cover some portion with some handful of sand, right, you can't see what is happening inside, it is covered with sand. Just like that, some flux or granular material is provided here. So the total weld area where the arcing is taking place is not visible from outside. But in MIG welding or TIG welding, you can observe what is going on, what is happening, because this is a clear gaseous envelope. But instead of gaseous envelope, here some flux material is provided by hopper. And as the welding is completely continuing under this blanket, so this is known as submerged under a blanket of granular flux. And this is also protected from the atmospheric contamination, not by gaseous shield, but by the blanket of granular flask. We also have in our workshop a submerged arc welding setup in Blue Earth machine shop. Now here, these are the description, some description, but important is, what are the flux actually? What is this material? Flux may be of two types. One is fused, another is infused or unfused. And we may have unfused. One is fused flux, one is unfused flux, or say known as bonded flux and agglomerated flux. So we are not going through detail. You go through any book, so things are there, not in detail. You just learn at least partially. But this is unfused. These are the detail. But say this is the list of what are the materials: submerged arc welding flux type. MS is a code. What is that material? Manganese silicate, manganese and silicate. And what are the major ingredients? Manganese oxide, silicon oxide, SiO2, SiO suffix 2. And it is greater than 50%. And what are the features? Silicon and manganese transfer is possible together with wires of low manganese content. So these are some description, but there are many more, like calcium silicate. What are the ingredients, major ingredients? Calcium oxide, magnesium oxide, silicon oxide, greater than 60%. Similarly, AR means aluminate rutile, where ingredients are Al2O3, aluminum oxide plus titanium oxide, TiO2. FB fluoride based, calcium oxide, magnesium oxide, manganese oxide, calcium fluoride. Or we may have silicon oxide, calcium fluoride. So not a single material, but so many ingredients may be bonded together. So this is the flux. Or this is again a research area where several researchers are developing various fluxes using different materials in different quantities, proportions, and experimenting. Okay, so this is the submerged arc welding. Atomic hydrogen welding is another advanced welding technique where the heat, all these are nothing but to provide the heat source. Atomic hydrogen welding, it is a thermochemical, both thermal as well as chemical reaction is taking place, both thermal and chemical, thermochemical. Now how heat is obtained here? Heat is obtained by passing a stream of hydrogen through an electric arc struck between two tungsten electrodes. So here you just observe there are two electrodes. Tungsten electrode, again one electrode, tungsten electrode. So as soon as they are struck, this is the workpiece. This is not connected with any polarity. But the terminal, this is the AC transformer set where 3 volt, 300 volt is the rating. So two terminals are connected with two tungsten electrode, mind that, not with work. And here hydrogen is passed. This is a inert envelope. Sorry, not inert envelope. This hydrogen, this is atomic hydrogen. So as soon as these two electrodes are struck, so one arc will be formed here. The shape of the arc is fan shape, this fan shape. And as soon as hydrogen is fed from another cylinder, here cylinder, hydrogen is fed here, okay, so that will be converted into atomic hydrogen, getting the very high heat. So that is the concept. Heat obtained on passing a stream of hydrogen, here a stream of hydrogen is passed through an electric arc. This is the electric arc, so hydrogen is passed and the heat is atomic hydrogen is produced and enormous heat is produced. Filler rod may also be used or may not be used depending on the requirement. There are various technical details, complexities, but you don't go for that. You just draw a schematic diagram with proper level and just discuss the phenomenon. Two electrodes are striking, that is the principle, and hydrogen is fed in this fan-shaped arc. So atomic hydrogen is produced and tremendous amount of heat is generated. And the shielding gas is also, this is also hydrogen shielding, as the hydrogen is fed here. Okay, atomic hydrogen. So these are the description. Gas welding we have already mentioned. What we told to start with, these are the gas welding. Oxygen cylinder pressure 125 kg per square, high pressure, all these are high pressure, or 2200 psi. Acetylene cylinder 16 kg per square centimeter. But you must, what I told yesterday also, you must use some regulators, gas regulators or pressure valves, all these, because our line pressure or working pressure for oxygen is about 1 kg, for acetylene about very low 0.15 kg. But cylinder pressures are very high, so you can't utilize directly. So there must be regulator valves, pressure, two-stage pressure regulator valves and all these. Check valve, all these, very important. Check valve, because otherwise explosion may take place. Because our working pressure should be for oxygen 1 kg, for acetylene 0.15. These are the setup. All these valves, regulators, all these are there, knobs. And this is the cables, this is the torch. These are the flames. Again, in any book, these are not very good picture, but in any book you will find there are various inner cone and 3 heat zones. Inner cone here in between some 1260 degree. Here this is 2300 degree Fahrenheit and so on. Oxidizing flame, some nature is something. Carbonizing flame, there are 3 distinct zones, and neutral flame. But here neutral flame, oxidizing flame look same, but here for oxidizing, the inner cone is very sharp, pointed, but here it is not that pointed. And here this is also bluish in color with a hissing sound. for oxidizing. Again, these are the some write-up. Now these are the reactions what we mentioned yesterday, or acetylene C2H2 plus oxygen. But this is say complete combustion. What is here? All these are written. That is second stage, first stage combustion. Don't worry. Neutral flame, oxidizing flame, reducing flame. And these are the comparative say pictures of the various flames. Neutral means when oxygen and acetylene 1:1. Oxidized means oxygen portion is dominating over acetylene. And reducing or carbonizing means acetylene portion is dominating over oxygen. Obviously, it will be incomplete combustion. So outer envelope will be some yellowish. All these are neutral, and temperature is important. This is say oxidizing of 1.5:1, maybe oxidizing. Reducing, maybe reverse. Now gas cutting, what we had mentioned, gas cutting, ferrous metal is suitable because iron oxide is produced first. This is the reaction Fe3O4 plus this much of heat. And this is approximately 1 cubic feet of oxygen is required to oxidize about 3/4 cubic inch of iron. Now this is important. Another two important aspect is bridging and soldering. You are also familiar with these two terms, that is soldering and bridging. Particularly in electrical wiring, electricians, they use this shoulder torch, right? So that is a low heat technique, low heat joining. And this is a method again, not this is not the concept of welding, uh, because both the parts are not heated, not bring to the fusion point like that. But how the joint is made? The joint is made by means of a fusible alloy. Fusible alloy is known as solder. For that, we must have a solder iron. So before starting the operation, the solder iron is heated. The electrician, when they are coming, they are plugging the solder iron for some time. When heat is sufficient, and heat is not that high, only melting range of the solder material is only 130 to 350 degrees centigrade, depending on the material. So after initial heating, that solder is melted by using that solder iron. You just remember, I don't know whether you are familiar with, there is a can, small can or tin, where solder iron is the paste is there. And this is the solder rod, soldering iron, right? Okay, it is connected with a cable and a plug, all these. So when this is plugged in and this is heated, this tip is heated to about 130 to 350, and this is now dipped into this paste, which is called a solder. And again, depending on the components, there are soft and hard solder. What is soft solder? Soft solder is only used for joining wire. This electricians, they use this soft solder wire or very small parts. Plumber are also using, plumbers. So where soft solder means this material, soft solder material is a mixture or an alloy, a composition of lead and tin mainly. This lead and tin. Okay. And what is this Sorry, I'm sorry. In this can, there is a, not the shoulder. This is a can containing the flux. Okay, flux, and shoulder wear looks like a small wear. Okay, small wear, and this is the shoulder iron. Now it is heated first, dipped into the flux, and then it is also placed under this heated tip, so that will be melted. This tip will be melted, and say this is to be joined. So this shoulder tip is placed here, heated shoulder tip mixed with this flux, and then this will be melted and will be deposited here. So here, in case of soft shoulder, where soft shoulder means the material, that is alloy material, fusible alloy material, they contain only lead and tin. Number one is soft shoulder, where 37% is the lead, 63% is the tin. If it is medium shoulder, 50% lead, 50% tin. Plumber shoulder, 70% lead, 30% tin. Plumber, the water connection, etc. are made. 70% lead, 30% tin. But electrician, they use 58% lead, 42% tin. Another term is bridging, that is also a joining. It is also similar to soldering, but it will give stronger joint than the shoulder joint. The joint will be much stronger. And here a filler metal is used. Here also a filler metal is used, a flux metal, not filler metal. Here is a flux metal is used here in shoulder, which is basically zinc chloride. Zinc chloride. The tin, the can or tin contains a flux material which is nothing but zinc chloride. But zinc chloride is a corrosive. Still it is used. And when the alloy is made with tin and lead, this is called soft shoulder. And when this alloy is prepared with silver, with tin, not lead, if this is replaced by silver, Ag, and tin, then it is used as hard solder. What is the difference? The melting range is now from 60 to 900 degrees centigrade instead of 130 to 350. So these are soldering. And bridging is also same, but here this is something is used for mass production. And here a filler material, hard filler material is used, which is known as a spelter. This is a technical name, commercial name, spelter. And these spelter filler metals may be either copper based alloys or silver based alloy. For hard, very hard, silver based alloys. For softer, copper based alloys. Accordingly, their melting temperature is very high, 850 to 950. So just like soldering. Spelter is a technical name. Spelter is particularly connected with bridging. This is a filler metal. So soldering and bridging. So these are discussed. We had discussed. So these are some figure of this spot welding. So a weld electrode, and here this circuit is there. This circuit, this part obviously will be there. Okay. This left hand side will be there, and this is electrode. This is electrode. From this point, this is. But this part obviously you must draw during your examination. You must draw this part also. That is the other part. Okay, so this primary coil and power line, all these. হ্যাঁ হ্যাঁ হ্যাঁ, ওইটা আঁকতে হবে, ওটা কমপ্লিট ফিগার হবে, যে কোনো বইতে দেখবে বুঝতে পারবে। দিস ইজ সিম ওয়েল্ডিং, just roller electrode is used. So it is rotating, so position is changed, and continuous welding spots, continuous spots are developed, looking like a seam. This is projection, just this upper part is dimpled, or a corrugated shape is provided, so that simultaneously all the spots are getting heated, and at it in a single pressure the welding is made. Flash butt and offset butt. In flash butt there is a gap and arcing, and now you understand how the arc is established, arc column theory. So this is the nature after the joining, a protruded portion, a nugget shape is obtained. And here this is flash butt, but offset butt means both the ends are connected. There is no gap. Now laser beam I am not discussing today, if possible, because today there are some other laser beam welding and electron beam welding. So something like this. So next class we shall. So this is laser welding and thermite welding. Okay. So in the next class, electron beam, thermite welding, those will be discussed. Is it okay, or should we discuss today?
স্যার আজ এতটাই থাক স্যার।
স্যার আজ অবধি এতটাই থাক।
আচ্ছা আজকে এতটা অনেকটাই হয়ে গেছে, একটু দেখবে বই। So next class means next Friday. So
Yes.
we shall discuss the rest portion along with some other. So we are almost in the verge of completion, because after discussing laser beam, electron beam, and what is that? This কি বললাম? Thermite, yeah. Thermite is chemical. So after discussing those things, then we shall switch over to our almost the last portion, that is the additive, generative manufacturing or additive manufacturing. That too in a nutshell, because just that is the introductory additive manufacturing, right? So that with
Okay,
that we
sir.
shall conclude. Any question? Okay then. So you send me CR, you send me the attendance also. Okay then. Okay, good night.
Okay, sir. Okay, sir. Thank you, sir.
গুড নাইট স্যার।
Good night. Good night.
Good night, sir. Sir has left. সৌম্যদীপ, সৌম্যদীপ,
বল।
পাঠিয়ে দিস।
হুম।
দীপ শালা ক্লাস শেষে ঢুকছে, কি ছেলে রে, এখনই ধরা পড়ে যেত।
না না, ক্লাস ছিল বলে এখন এটা ঢুকলো, বলা অ্যাটেন্ডেন্স নেই বলে ফোন করলো।
যখন তোকে যদি অ্যালাউ করতাম না, স্যারের সামনে পড়ে যেত একদম। স্যারের স্ক্রিন ওপেন ছিল,
তারপর দিতে ছিল ক্লাসে।
আচ্ছা ঠিক আছে, ঠিক আছে, নাইস। ঠিক আছে, সৌম্যদীপ পাঠিয়ে দে। হ্যাঁ
সবাই অ্যাটেন্ডেন্স পেয়ে যাবে। হ্যাঁ হ্যাঁ হ্যাঁ, সব পেয়ে গেছে সবাই। ঠিক আছে, অ্যাবসেন্ট করেছে 2 জন, তুই আর বিশাল। আরো 2 জন বাকি আছে। ও অনন্যা ঘোষ আর সমীর ঘোষ। সমীর আর বলতে নি, ঘন। ও আচ্ছা,
ঠিক আছে। আর রেকর্ডটা পাঠিয়ে দিস। হ্যাঁ,
রেকর্ড তো কি করেছি কিংসু।